Welcome to the lesson. Today we are looking at rocks and what? Minerals. You already know what rock is by saying it, is it not? But we're going to look at how this rock came into what? Existence, and how they normally form, and how they are what? Classified. Okay? And then we're going to be knowing what minerals are. In case of next time, when you see a mineral, you know what a mineral is it not? Yes. When I talk of mineral, I'm not talking about the Fanta and the Coke you are drinking. Oh, yes. Okay? Now, what you must know is that the entire surface of the earth is made up of rocks. Okay? The ground you are standing on is rock. The ground underneath the river, the lakes, and the ocean is also made up of what? Rock. Rock is a hard, solid material that is made up of what? Minerals. When we see rock, we should remember what? Minerals. What are minerals? When we talk of minerals, we are talking about when elements combine together. Okay? Most minerals are formed when elements combine together. What is an element? An element is a naturally occurring substance that is what? Found in and around what? Earth. They are the smallest form of matter, and they cannot be what? Broken down into smaller pieces, is it not? Yes. So the elements combine together to form what? Minerals. And the minerals at the end of the day will combine together sometimes or stay alone to form what? Rock. Is it not? Yes. There are currently 94 naturally occurring elements that have been discovered. If we combine certain elements, it will produce what? Minerals. What actually causes the formation of these minerals? Whether natural disaster like earthquake, tsunami, hurricane, avalanche, tornadoes, and human activities, we always affect which element come into contact with one another. And then the element that come with one another will not decide what kind of mineral that will be formed. And then the kind of mineral that will form will not determine what kind of rock that will be formed. That tells you that there are different kinds of what? Rock. Even though there are different kinds of rock, they are classified into three. Now take a look at this. Rocks that I'm talking about can be big, like a mountain, and then sometimes can be small, like the sand you are standing on. It can be rough or it can be smooth. Sometimes the rock are round, while some are circular or triangular. Sometimes some rocks are black, while some are white. They come in many different forms and they have different what? Properties. Regardless of what? The properties of any rock, they are always made up of what? Minerals. All rocks are made up of minerals. Because of these facts, all the rocks that are formed are classified into three types. The first one is igneous rock, the second one is sedimentary rock, and the third one is metamorphic rock. I say it again. The first one is igneous rock, say it. The second one is sedimentary rock, say it. And the third one is metamorphic rock. Now, each type of rock is formed in its own unique method and has its own unique what? Particular what? Characteristics or behavior. There are people we call geologists. Geologists are scientists that actually explore the three states of matter that can be found on the earth. Solid like minerals, geologists exploit them. They go and look for them and search and know what they are made up of. Okay? Liquid like your petroleum, geologists go and search for where we can find them. Gases like your natural gas, the one used to cook at home, geologists also go and check where we can find them. Okay? Because geologists do a lot of this, they now come up with ways to identify these minerals. For example, they use what we call a streak test. A streak test is when a mineral is scraped along a surface to see the color of streak that it leaves. So if I pick a mineral or a rock and drag it along a wall, the color that it will give to me will determine what kind of minerals is present in that rock. Another one that we do is that we'll break it. When we break it, the way it will break apart will determine what minerals are present. Sometimes it will break into smaller pieces, while sometimes it will break into larger piece. The most common things that geologists will look for to identify minerals are 1. Their color, 2. Their shape, 3. Their structure. But the only way to really be sure of the minerals that are present is to look for the chemical makeup. How? You take a microscope and look at the chemicals that are present. You know what a microscope is? A microscope is a device that allows us to see what our eyes cannot see. Okay? Yes. These are too tiny for our eyes to see. One of the most famous tests we use to test minerals is hard test, and it is called the scratch test. See the scratch test? The scratch test was created by a German mineralogist named Frederick Moore. His name is Frederick Moore. He developed a system of comparing the hardness of mineral called the scratch test. How does the scratch test work? He took the 10 most hardest material. These are the 10 most hardest minerals. Number 1, we have talc, we have gypsum, we have calcite, we have fluorite, we have apatite, we have feldspar, we have quartz, we have topaz, we have corundum, and then we have diamond, which is the hardest. Now, in testing the scratch test, you will take the material that you want to test and scratch it against any of these material. Let's say I want to test an unknown material. I will scratch it against the first one there, talc. If I scratch it against talc and then talc scratches the material, it means that talc is harder than the material. But if the material scratches talc, it means the material is harder than talc. I will now take it to the next material and scratch it on gypsum. If the material scratches gypsum, it means the material is harder than gypsum. But if gypsum now scratches the material, it means gypsum is harder than the material. Therefore, since the material scratches talc, the material is harder than talc. And since gypsum scratches the material, gypsum is harder than the material. Therefore, the hardness of the material is in between talc and gypsum. Do you get it? But if I scratch the material with talc and then none of them scratch each other, it means the material and talc have equal hardness. Do you see it now? The scratch test presents 4 conditions. I will still explain it to you as we go further. Let's look at when minerals grow. The atom will come together in an orderly repeating pattern. When this happens, we say a crystal form. What I say, we say a crystal is formed. And that crystal that is formed is called a crystal structure. Okay? So a crystal structure is formed when the material combine together in a repeating pattern. Okay? Crystals look like 3-dimensional shape. Each type of the mineral has its own specific type of crystal shape. Geologists often use the shape of a mineral's crystal as a way of identifying them. You see it now. The geologists use the shape of the crystal. When we talk of crystal, in short, you are going to be building crystal so that you know what the crystal is, okay? And when we talk of 3 dimension, we mean something that you can see from the 3 points. You can see it from horizontal, you can see it from vertical, you can see it from diagonal. Okay, that's what we mean by 3-dimensional. Gemstone, let's look at gemstone. What are gemstones? Gemstones are also called precious stone. Okay, a gemstone is the best and most beautiful part of mineral crystal. They are often sought out and mined specifically to sell as feature part of jewelry. Gemstones are valuable because they are beautiful and they are often very difficult to to find. Some of the gemstone or popular known gemstone are diamond, rubies, sapphire, emeralds. Each gemstone has a typical color tone. Diamond, for example, are usually clear. They don't have color. You can see through them, is it not? Yes, they are shining, very beautiful, attractive. Rubies, on the other hand, are red. They are also shiny. Why? Because they have crystals. Okay. Sapphire are blue, the one you are seeing on my screen right now. And then emeralds are what? They are green. Before a gemstone become exactly as you see it in stores, it must be cut to a particular pattern, cleaned and what? Polished. Do you see it now? Yes. Making salt crystal. Your project for this week is a salt crystal formation by what? Slow evaporation. So you're going to be making crystal. Get your lab coat ready. Alright. Let's look at igneous rock. The igneous rock, I told you there are 3 kinds of rock. Is it not? Yes, I told you I have igneous rock, sedimentary rock, and what? Metamorphic rock. Each of these rocks are formed in a different way. That's why I want to look at how igneous rock is formed. But before I talk about how igneous rock is formed, you need to understand that the earth itself is very big, is it not? As big as the earth is, it has what we call layers. They are arranged, the materials are arranged in layers. Okay, the first and most inner layers is what we call the core of the earth, and it is made up of iron. The next layer we have is the mantle, okay, which consists of what? This rock I'm going to be talking about. And then you now have what? The crust. The most outer layer of the earth is called the crust, which is followed by the mantle, and then the outer core, and then the inner what? Core. The crust is made up of rocks and minerals. A large portion of the rock that forms the earth's crust is what? Igneous. All igneous rock is created when molten rock or magma from under the earth's surface cools and hardens. The magma can harden in 2 ways. Now let me explain what I'm saying. Under the earth is very hot. Okay, the core of the earth is made up of iron, I've told you. Then you have the mantle of the earth. The mantle is divided into 2. You have the upper mantle and the lower mantle. The lower mantle is very hot. Too much heat causes the rock that are in the upper mantle to melt. When they melt, they begin to flow. When they are flowing, we no longer call it mantle. We now call it what? Magma. Because the rock has melted and is not flowing. This magma is actually a flowing what? Liquid. It will not flow to some point and then it will what? Cool down. When it cool down, it will form a rock. That kind of rock that is formed when magma cools is called igneous rock. Now, the cooling and the flowing is of 2 kinds. There are times that the magma will flow under the earth and cools and form rock. That kind of rock is called intrusive igneous rock. Say it. Say intrusive igneous rock. Yes. Why there are times where the magma will flow out of the surface of the earth. It will flow out of earth and come out of the surface. Okay, and it will also form rock. When the magma flows out, it is no longer called magma, it is called lava. Say lava. Lava. So when lava cools, it will form igneous rock. You know it has come out already, is it not? And it is forming outside. So that kind of rock is called extrusive igneous rock. Say extrusive igneous rock. Extrusive igneous rock. Now inside the earth or outside the earth, if the cooling process happens underground, the rock that is formed is classified as what? Intrusive. So we have intrusive what? Igneous rock. But if the magma cools and hardens above the earth surface, which is called lava now, it is classified as what? Extrusive igneous rock. Say extrusive igneous rock. Extrusive igneous rock. Now rocks are formed because of what? Eruption of an active what? Volcano which spouts out lava. You see it now? Yes. These rocks are formed because of what we call volcano. You are going to be learning about volcano in the next lesson. Okay? Both intrusive and extrusive igneous rock have certain characteristics that allow scientists to classify them as igneous rock. For example, the size of intrusive igneous rock is usually very large, is it not? Yes. While that of extrusive igneous rock, we have crystals that are small, because the rock itself is small. Do you get it now? Yes. So this is a picture of what I'm telling you. Can you see the earth? Look at the magma under. Okay? The magma is red. When it flows and cools like the one you are seeing on my right hand side, when it cools at that level, it will form what we call intrusive igneous rock. But when the magma flows, can you see now? It is flowing passing the upper mantle, going down to the crust and appearing on the surface of the earth. When that happens, at this point, we no longer call it magma, we call it lava. When the lava now cools, it forms what we call extrusive igneous rock. Say it. Say extrusive igneous rock. So you now know that igneous rock is of two kinds: intrusive and extrusive. Intrusive is formed as a result of cooling down of magma, while extrusive is formed as a result of cooling down of lava. Do you get it now? Yes. Now, igneous rocks are easy to find, although a large portion of them are buried underneath our feet. If you go anywhere in the world that has an active volcano, okay, when we talk of active volcano, we are talking about an area that has a tectonic movement. When we talk about tectonic movement, we have what we call tectonic plates. All the earths are made up of tectonic plates. These plates tend to move, and they have been moving. I'm going to explain more to you. When they move, they causes what we call volcano. It is the volcano that causes earthquake that you see at times. So when this happens, it will causes magma to flow. And when magma flow and cools down, igneous rock are formed. Some of the more common types of igneous rock are obsidian, pumice, rhyolite, andesite, basalt, granite, diorite, gabbro, porphyry, and pegmatite. Scientists can identify these rocks based on their textures, colors, mineral content. For example, obsidian and pumice have a glass-like texture. So you see some of the rock I'm labeling. Alright, these are some of the igneous rock. Let's now look at how sedimentary rocks are formed. We'll talk of sedimentary rock, we'll talk of sediment. Say sediment. Sediment are actually small piece of materials. So sedimentary rock is formed over time when rocks and mountains formation erode. What do I mean by erode? They are carried away by exposure to wind, rain, snow, and heat. So when they break, when mountains and rocks break into smaller particles, and then they are carried away and deposited under different areas, such kind of material are called sediment. Now, sediment is carried away by wind and flowing water such as streams and rivers. Eventually, the particles gather on the ground and underwater, and they are squished. Okay, when I say they are squished, I mean they compress together. Over time, more and more particles will now come together, and they now form layers of sediment. Do you see it now? Most of these layers of sediment, usually they have many different visible layers in them. This look is called stratified look. Say stratified look. You know, when plant die and they decay, is it not? They changes to what we call foci. Some of the particles are carried along, and then they will now combine together and be forming layers. They will not mix together. Sand will be on its own. Foci will not join it. Plant foci will join. Animal foci will join. Another kind of rock type will join. At the end of the day, you now see them, they have different layers. How do you know they have different what? Colors. Okay? Because of this kind of look, we call it a stratified look. Alright? Now, there are three main types of sedimentary rock that are formed. They are clastic, chemical, and organic what? Clastic. Clastic sedimentary rock is formed from weathering and erosion of existing rock formations, such as mountains, which eventually recollect as small pieces and compresses together into new sedimentary rock. Most sedimentary rock will form in this way. Some examples of classic sedimentary rock are, you have breccia, you have conglomerate, you have sandstone, you have saltstone, and then you have shale. Do you see it now? So classic sedimentary rock is formed when rocks, mountains break into smaller pieces and they are carried away and assembled in layers together. Such rock are called sedimentary rock, and they are the most common of all sedimentary rocks. The other one is called the chemical sedimentary rock. From the word chemical, I already know it is not formed from what? Sediment. Instead, they are formed when elements and minerals that have been what? Dissolved in water are left behind after the water have what? Evaporated. Remember I told you just now that they are carried away by erosion, is it not? Yes. Those ones that are carried away by water, they will not form together when the water has what? Dried up. These are the elements too. The elements will not combine together when the water has dried up, and then to leave behind these minerals that form crystals as they dry. Those crystals are what become chemical sedimentary rock. Okay? Some examples of chemical sedimentary rock are rock, salt, iron ore, chert flint, certain dolomite, and then certain limestones. So these materials that I'm calling are very, very rich and useful minerals that we use in doing many things on earth. Okay? For example, your iron ore is where we use to make iron. Or your iron, your protector, everything that got it from your iron ore. So do you see that chemical sedimentary rock is very important? Yes. We now look at the third one, which is called organic sedimentary rock. When you hear the word organic, we are talking about the one that are formed from plants and what? Animals. Informal from organic sedimentary rock is formed from accumulation of plant or animal debris in forests or areas that have an abundance of living organisms. Dead plant and animal matter stays on the ground and eventually will be buried by what? Dead sediment and other dead plant and animals materials. As layers and layers of this matter build up and get buried, it begins to form what? Compacted layers of what? Organic sedimentary rocks. Some examples of organic sedimentary rock are what? Coal, certain dolomite, and certain what? Limestone. Specifically coal, is very important, is it not? Why? Because it's a natural resources, is it not? Yes. So look at some of the beautiful sedimentary rocks. Okay. We now look at the last one, metamorphic rock. Metamorphic, just like the way igneous means fire, sediment means small. Metamorphic means to change. Okay. Metamorphose means something changes. Okay. They are formed from the transformation or change of igneous, sedimentary, or even the metamorphic rock itself. So when igneous or sedimentary rock changes due to heat or pressure, the new rock that is formed is called metamorphic rock. Do you understand now? I'll take it again. When igneous rock or sedimentary rock or even the metamorphic rock itself changes due to high pressure or heat, the new rock that will be formed is called what? Metamorphic rock. For example, when igneous rock that is called granite is heated and pressurized, it will turn into a metamorphic rock that we call gneiss. Do you see it now? Granite will change to gneiss Another example is when shale is heated, it will change to slate. There are two main ways in which metamorphic rock can be formed. I didn't say two types of metamorphic rock. Oh, take note. The ways in which metamorphic rock form, there are two. We are talking about the way metamorphic rock is formed now. The first one is called the contact metamorphism. Say contact metamorphism. In contact metamorphism, the existing rock will change as a result of the heat. I told you before that lava, remember lava or magma? Yes. When the heat of magma now touches a igneous rock, are you getting it? Remember, I didn't say cool. I said the heat of magma will hit igneous rock that has already been formed. It will form a metamorphic rock. When the heat is very close, we say that rock was formed as a result of what? Contact. Okay? Now, the distance of the existing rock from the pool of magma will determine how much rock changes. Okay? The other one is called regional metamorphism. Regional metamorphism occurs over a much greater area than contact metamorphism. What I mean is that in contact metamorphism, the magma is very close to the igneous rock, and so it will change quickly. Is it not? But in regional metamorphism, the magma is very far from the metamorphism. Therefore, this type of metamorphism occurs from rock simply being underground and constantly subject to high temperature of Earth's core and under the extreme pressure of what? Weight of the rock layers on top of it. What am I saying? What I'm saying is that in regional metamorphism, the heat is very far. Okay? The heat is far away. So therefore, it will take time before it will change into what? Metamorphic what? Rock. And this kind of heat is due to the core and the mantle that are far away. Okay? So the type of rock that is created depends on the starting what? Minerals. We want to look at the type of metamorphic rock now. Do you see it now? I've talked about how it is formed. It is formed in two ways: contact and regional. Contact means the magma is very close to the igneous rock or sedimentary rock. Why regional means the heat or the pressure is very far from the what? Igneous rock or what? Sedimentary rock. But it will heat it over time and then it will form what? Metamorphic rock. Okay? But when we talk of the type of rock that is created, depend on the starting minerals. The type of metamorphic rock that will be formed now will determine the minerals that was present. Okay? And then the fluid condition associated with what? Metamorphism. That is how the liquid or the magma flow. It is on this basis now that we now have two types of metamorphic rock. I am not talking about types of what? Metamorphic rock. There are two ways in which metamorphic rock is formed, and there are two types of metamorphic rock that is what? Formed. The two types of metamorphic rock that is formed are foliated and non-foliated metamorphic rock. So foliated metamorphic rock have a layered or banded appearance that is produced by the folding of pre-existing rocks under extremely high pressure and fast cooling what? Minerals. Some examples of foliated metamorphic rocks are slate, which is formed from shale, pyrite, schist, and gneiss, which is formed from what? Granite. Is it not? Yes. So when we look at foliated metamorphic rock, we look at rock that are basically formed from what? The first method or the first pattern, which is the contact. Is it not? It heats quickly and cools quickly. When it heats quickly and cools quickly, the kind of rock that is formed is called foliated metamorphic rock. Is it not? Yes. Why the non-foliated metamorphic rock do not have a layer or banded appearance? They usually form under extreme high temperature and very low temperature also. even amount of pressures and cooled very slowly. Do you see that? They cool very slowly. This allows the minerals in them to form large identical looking crystals. They are tightly packed together. Some examples of non-foliated metamorphic rock are what? Unfez, marbles, and what? Quartzite. Okay? So these are the examples of what? Non-foliated metamorphic rock. Common metamorphic rock changes. I told you that metamorphic rock are formed when sedimentary and what? Igneous rock are changed due to what? Heat and what? Pressure. So limestone, which is an example of what? Sedimentary rock, when it undergoes pressure and heat, will change to marble, which is now the new metamorphic rock. Granite, which of course is igneous rock, will now change to what? Gneiss, which is now metamorphic what? Rock. Shale, which is a sedimentary rock, will change to unfez. Shales, which is a sedimentary rock, will also change to slate. Shale, which is a sedimentary rock, will also change to schist. Slate, which is a metamorphic rock, will also change to phyllite. While sandstone, which is a sedimentary rock, will change to quartzite. Why are they changing? Because of what? Pressure and what? Temperature change. Okay? You must note that the same rock can change into a different rock based on how much pressure and heat is what? Exposed to. So look at metamorphic rock. You can see them: quartzite, slate, marble, gneiss, schist, and what? Serpentinite. Okay, these are examples of what? Metamorphic rock, and they are formed from where? Igneous, sedimentary, and metamorphic rock themselves. So I want you to watch and listen, learn how these three rocks are formed. Pay attention to how they are formed, okay?
Rocks are everywhere. They are large and small, heavy or light, porous or dense. But rocks in some shape or form can be found all over the planet. Different types of rocks are formed in different ways. There are three main types of rock: igneous, sedimentary, and metamorphic. Igneous is a word that means fiery. Igneous rock is formed when magma or lava cools. Sometimes magma cools slowly underneath the Earth's surface. This forms intrusive igneous rock, like granite. Other times, lava cools when it comes to the surface in a volcanic eruption. This forms extrusive igneous rock. Some examples of extrusive igneous rock are tuff, obsidian, and pumice. Igneous rocks make up about 95% of the Earth's crust. The next type of rock is sedimentary rock. Sediment is small particles of sand, mud, and organic material that settle to the bottom of water or land areas, often lakes or oceans. Sedimentary rocks are formed when sediment accumulates over time in deposits that form layers. These layers become squeezed and compressed over time until they consolidate into a rock. Sedimentary rocks are the types of rocks in which fossils may be found, since the process of forming sedimentary rocks can preserve plant and animal remains that are deposited into the sediment layers. Some examples of sedimentary rock are limestone, shale, and sandstone. The third type of rock is metamorphic rock. The word metamorph means to change form, and metamorphic rock is rock that has been changed by extreme heat and pressure. Sedimentary rock, igneous rock, or even other metamorphic rocks can be changed by heat and pressure into new kinds of rock. Metamorphic rocks can be formed by being deep under the earth where pressure and temperatures are high, or when rock near the surface is heated up by the movement of tectonic plates or magma. Different types of rocks become different types of metamorphic rock when exposed to heat and pressure. For example, shale becomes slate. Sandstone becomes quartzite. And limestone becomes marble.
Welcome back from that video. I believe you now know the entire surface of the earth is made up of rocks. You now know what crash test is, huh? And you now know that color helps us to identify rock, is it not? You now know that if we combine certain elements, we will form minerals. And when minerals come, they form rock, is it not? You now know that rock are of three types, is it not? Igneous rock, sedimentary rock, and what? Metamorphic rock. And then you now know how they are formed. You now know that metamorphic rock are formed from what? The transformation or the change of igneous, sedimentary, or even metamorphic rock themselves. That now brings us to the end of today's lesson. I want you to do the other activities and get ready for your crystals.